With Stable Diffusion and Comfy UI, there's a lots of way to do animations. In this tutorial, I'm going to create a workflow with segmentation mask, IP adapter, and differential diffusion to create more consistency style of video animation. And also using LCM checkpoint model, we are able to improve the speed of generation process. Let's get started. Hello everyone! So in today's video, I'm going to explore the differential diffusion. Now, this is a really cool feature and it's already included in Comfy UI. It's by default in the Comfy UI nodes themselves if you have the updated versions. Basically, this is for input mapping of the image, and once the image is inputted, it can be masking the areas of the image and create another output with the shape or form from your input image. And this is really cool. Once I explored more about this paper, well, it's not a new paper. It's already been public for a while. But I'm trying out a lot of masking. How can we customize it for the differential diffusion workflow? How we can use different methods like IP adapter, segmentation, masking, all kinds of methods. And I've been researching this one recently and playing around with it, and the results look pretty nice. Actually, some images here aren't working. Let's see if there's something we can show. But right here, you can see the soft in paint section in this paper. It really shows the input elements, how you can inpaint a mask to an output image like this one that we can reform with the same original image structure. And I realized, what if we can do that with differential diffusion? Generate new animations with this kind of form and put that into like a character, the movement, the dancers, for example. We always use dancers as a practice example for how we can change the total outfit and the outlook of the character with the same shape or form. You know, have their movement stay the same, but then the style looks different. So for example, like this, the old Templar change to like a post-apocalypse city, something like that. And yeah, maybe we can use masking like that. So in my previous workflow here, I did field masking method. This is the good old Coco segmenter that we've always been using, very accurate for segmenting characters, highlighted in red. And then we can do a growth mask and mask blur to make the edges smoother in order for the image mask to be generated well in differential diffusion. We also tried with segment anything using a prompt segment here. And then we can combine a mask with the original image frame together and pass it out to a masked data. And both of those are working okay. But what if I want to just change a jacket or change just part of the character's outfit without dealing with the backgrounds and everything? And I found that in the automatic extension, we also have one called a person mask generator, and this one is doing quite fast. Previously, we played around in automatic, and I saw that they also have the Comfy UI custom nodes available for download, so we can try this out as well. So combining the masking using Coco Segmenter or the segment anything or using this person mask generator, we can pass that data. And for example, in the Comfy UI KJ nodes that I've always been using, we have the set and guess nodes to define values. And they also have the growth mask with blur. So you can just put one custom node like that and control the masking, growth, and the shape or form before you pass that to differential diffusion for doing the masking for the character's outfit, etc. What we usually did in the workflow here is we can do IP adapter masking that we always did using a masked character image, and then we pass that to the IP adapter tile here with our reference image. So it's okay. We're not going to stick with one method always, but sometimes it depends on the situation. If I just want to change the character, then I'll enable this group. If I want to change the whole thing, the character and the backgrounds, then I'll be using this group because they have both masking for characters and the backgrounds in here. So I think this whole workflow is pretty complete already, and I want to do another new workflow based on this structure. But then I'll use another new method. Maybe I'll still stay using the Coco segmenter and also put the personal mask generator Comfy UI versions as an optional method for you guys to try. And that will be using also the different diffusions in by default in Comfy UI itself. So as you guys can check this keyword and you can go to Comfy UI and just put different diffusions. And you will have these nodes right here. It is by default in Comfy UI already. So what it does is that before you pass to the sampler between differential diffusion, you can use that in here. So for example, if I have a K sampler in the first differential diffusion sampling groups, I can put that between the rescale CFG and pass the model's data to this one. And it will be making the pixels, as it mentions, giving the pixels strength to modify between the mask mapping and also the input source image, or in our case, the input source video's image frame. And we'll have another pass of models data to the case sampler at the final step here. And also we can pass those models data to external parties, but this one is rarely used by myself. Usually we just generate this case sampler, we pass the image frame and also the latent image data and pass it to the second group to do a little latent upscale and make it clearer. And then at the final step, we'll be going to the detailer. Maybe enhance person, hands, face, whatever you want to enhance. So this workflow is pretty complete already, and I've posted it in previous videos already. You guys can check it out. But then I want to try out this new method, a simpler workflow without so many nodes connecting to each other. I just want to try with the IP adapter and the different diffusions and also using the Coco segmenter mask and the person mask generator to do that. And as we've played around with this before, in Automatic, this is a pretty fast generator for masking our character's face color, hair, the bodies themselves, etc. But then it's really just focused on characters. But, if we want to do masking for the backgrounds or we want to change the backgrounds, we want to enhance the other elements in the video, we need some other optional things. So we need the IP adapter to mask and the Coco segmenter to mask the backgrounds, maybe change something else in the video. So I'll be freshly newly creating another workflow based on this method and trying it out. So first we'll empty our workflow, just have an empty one. And I have some existing custom nodes that I can use, and that is of course the load checkpoint. So here I'll use LCM checkpoint models, or you can use other checkpoint models, whatever you want to. But I like to stick with Stable Diffusion 1.5 base checkpoint models. In here, I used a Real Dream Turbo LCM6 and will first, have a set node for that. So let's say I have, that is the Stable Diffusion model. Okay, I like to call that the model's base data. So once we pass the model's data out, we can do other stuff. For example, the clip layers, we have clip layers, and between the clip layers, of course, we have the positive and negative prompts. So I'll highlight this in green color and red color. So mostly for these two, I would just have my preset template for this. For example, I have something like this. Maybe I don't want the skin color. I just, put a preset text prompt in here because mostly we're using the IP adapter for the styles and influencing the characters and backgrounds. So here it's just a template for the text prompt. And secondly, we'll use LoRa's. Maybe you can use LoRa's in here to add details. If we're using LCM, so we get a little more detail for the characters themselves. So maybe we can do that as well. It's just, anything you can do in here as well. You don't have to follow exactly what I did. It's just the way I normally like doing it in here. And by the way, we don't need the clip layers themselves if we don't really need that. Yeah, so we can go for this way. Maybe we'll have another clip layer just for the settings. Maybe we can pass to other groups in the future. So let's say this is the clip layer data. Maybe that will be passing out to some other groups. So keep that as output data structure. Then we can do something starting from here, like the conditions. So in my case, I'll have control net. So maybe for the control net, I'll be first doing the pose. So here I have the control net, and you can search for pose, and that will be for this one. So pass this in, and here we're going to wait for the image frames from our input source video. So again, we'll have input source video from here, and I have, pre-rendered some animations before, so we'll have other styles later. It's easier to create. So by default, I always do 50-50 image frames as my default testing. And I'll say this is the global frame numbers. So we pass that out to other groups if there's need to use the image frames. And here's the other thing, it's the frame count, and then we can set that one out as well. And then in the meantime, we'll have to pass the resize image. And as I've just copied it from my existing workflow, here now I don't need to type it again with the same stuff that I'm using, and then we'll have the integer width and height that's also needed. So I just grabbed it from my existing workflow and plugged that into here, width and height. So let's say I'll put it in here. So one area for setting everything before we're executing all the data. And basically, that's it for loading our source image. And we're going to use the initial resize image from my resize image data here to pass to the control net here. So we'll use the get node, and here we'll connect the image. We'll select the resize image in here. And there we go, we have our first control net model. So right here, we'll connect the condition positive and negative here. And basically that's following the same thing. We're going with a soft edge, or you can use depth map. So for example, if you're using soft edge like the one that I used in the detailer, I want to try putting it up front this time. So we're able to use that to soften the character edges, etc. And pass this one as well, and the control net in here. So I like to switch over starting from my control net and pass the preprocessors as well, passing the resize image to the second control net area in here. And basically that's fine for our control net group. But one more thing I want to do is the depth anything, because I want to give a little more layering for our generated image, because it gives it more detail, like having more separation between the characters and the backgrounds. Sometimes it's good, especially for dance animations or TikTok videos like that. So there we have our most complete control net part. And lastly, we can pass those conditions out to positive and negative part. Actually, I can copy it from my existing workflow so I don't have to type that again. Yep. And positive and negative part is almost complete in here. So basically, this is the whole settings group for loading the video. And here, let's say I want to create this one called load video. And this is going to be in here. Let me organize this and we're good to go. Yeah, so this is the load video part. I'll put it on the top because that's the first step we've got to do, having the source video. And the second thing we've got to do is the loader group, which is loading from the checkpoint models, the LCM checkpoint models, and add some details with LoRa's and doing some template text prompts. And then we're getting the motions, the movement from the source video into the control net and passing that data into our conditions. So this is another one called the loader group. So this is like a long one that I always did by default in here as well. So right now we have the first step, load video, and the second step, loader group. And let's make this control net section one color so we can easily see it. And then the third step is we've got to inject the mask into the latent space. Now, this is another way to do that. Before, I would do the Coco segmenter before the latent space, but you can prepare the mask and pass the mask into the image frames together into the latent image. And while it's generating, it's just one process to generate the whole image frames with your IP adapters influenced image, so that way it'll be faster and smoother. We discussed that on Discord with other animation creators and found out that way is running better with LCM models. So in this new workflow, I'll try to do it like that here. So this is the segment mask group. So this is the third part. Maybe we'll have something from here to start on. One way to do that is using this mask. Basically, this whole mask can be copied to the new model, but then I'll try to use this one this time, just to simplify it, because we've done the Coco segmenter many times already. Maybe after this workflow is done, I'll put that one as an optional segmentation method. But this time I see using the KJ Notes Grow Mask with Blur and using the personal mask generator in here, we can, just directly install that and use that in ControlNet UI. So let's try this way. So in here, starting from the mask, of course, we need this get node and get the resize image. So once we have the image, we're ready to play with the masking. The personal mask generator can be found in here. You can do the automatic 1-on-11 style way to mask the face, skin, mask the face and bodies and the hair, or only the face, just like that. And that works for ControlNet UI as well, as you can see right here. So I'll follow this structure and create those. Let's go to our workflow here. So we've got all this resize image passed to the mask generator, and we got the mask out. Let's set a mask preview in here. We can see some mask preview in here, so you get an idea of what kind of masks you'll be expecting to receive once you have the mask. So this is one method by using the personal mask generator. If you just want to change the face, you can do that. Or if you want to just go for the background, you can do that. But there's pros and cons. The con is that you're only able to select either the characters or the backgrounds. Like for example, if I select the face, hair, and bodies and clothing, like almost the whole characters. But if you're masking the background as well, and if you enable the background mask together with the character part, that means the whole image is going to be masked. So it's useless if you're selecting everything in here. So basically I saw from this GitHub page that they're only selecting one certain thing at a time. And the maximum, logically, is either you select everything of a person or you select none of the things of the person and do the background only. That's the way it goes. And the confidence settings in here, just like the masking strength, maybe we set it like 30 or 25. Something like that will be good enough to mask a person or background using this one. So in this case, I would do a face mask, hair mask, and body mask and clothing as well. Just want to change the whole styles of the dancers in our videos. Or the other option is that we can use the Coco segmenter. This one we've used for many workflows. It's very stable. So I would just, basically copy this one into here, just have another option. The Coco segmenter, we're getting the frame count from our loader group. So the variables are the same because I've reused that from my existing workflow. So the width and height are also the same. Let's put it in this way, and then it's easier to see. Yeah. So this method is coming from Mateus's previous video talking about masking with the IP adapter. So this goes really well with using it with the IP adapter. So I have no problem using this one. So what it does is, we go to the Google segmenter, passing all the images into segmentation color, and we use this mask from color to transform each image into a mask. And basically, we are selecting mostly red colors. That means it's segmenting the characters in red, and we mask and grow that a little bit, blur it, and then we'll pass those into our image compression mask. And also, I have an invert mask here because this way I'll be able to select the backgrounds of the characters. And this is an empty image to compose the masks into images. And before that, we have another one called upscale image. Just have things from the source image to destinations and compose it into a new masked image list. So we'll connect this back to the image. And also this one, we have the Coco segmenter here. So this is one style of using the mask. I'll put that in yellow color as we used to do with this. Yeah, so that's one option. And the other option is only using the personal mask generator with just this one node here. So see which one can perform better for your scenario. If you like this style, a quick, lazy way to do it, you can do that as well. If you want to go deeper, dive into every segmentation setting and play around with all the parameters and settings, then the Coco segmenter is a good option in here. So let's move on from here. By the way, we need the output as well. So let's get this output from my existing workflow and put that in here as well. And we set the mask background, set the mask character, and we set the mask image, which is from here. Now, this is one method of outputting the mask, and this one is another way of outputting the mask as well. So for this new method, I would do that for the mask person. Let's name it something else like mask person gen, just, to better remember this mask data output. So this will go to the final destination here, and we have some preview images here. So it's easier to see what kind of data we have. So basically, that's for masking and segmentation masks. If you enable one of them, either one of them, then just highlight this part and do a bypass. And you don't need to run two things at the same time. Well, you can do that if your computer's processing power is good enough. But no, usually you don't have to do that. So the next thing we've got to do is start preparing for the latent image. So for the latent image, we're going to create one group for the latent image and sampling. No, actually it's latent image passed to the element diff. And right here, we'll use element diff as the center of this group. So we'll copy it from here. We'll do the LCM sampling and the VU2. Of course, we need that to make it clear for LCM data right here. And then we'll have this organized better, just tighten up everything. And then for the sampling in here, we'll have the sampling settings from noise. I recently like to use from model data. And that's basically it for the animated diffuser. And of course, before the VU2, we have what we talked about, the different diffusions. Search for this custom node. It's by default in the UI itself. You don't have to install extra stuff. So in here, we have the diffusions. Then we'll go to the K-sampler, and we'll have the sampling method. Everything runs in here. But then before that, we have to prepare our latent image as well. So in this group, I'll call that, animated prepare. So that way we can, prepare the animated settings and models, the motion models. In here, I like to use the version 3D motion models. And by the way, I'm fine-tuning this motion model for element diff, and it's in training right now. And hopefully there'll be some good results coming out in the future for the fine-tuned models. You guys can follow the updates in our Discord group. We've been playing around with that recently with some other animation creators, and yeah, so far this is what we have. And the next thing is we have to receive the mask from the segmentations here. So like this one, let's try this one. The person mask generator will have that mask gen person, and we've got to use the JK Notes growth mask with blur. This is, well, just the same concept as here, as we have the mask growth and mask blur. That's the same concept. But then JK Notes combines two things into one custom node, and it's a very compact way to make things. So why not use it, right? As you can see, the settings of this are very similar to the mask growth and mask blur that we use for the Coco segmenter group that's expanded. You've got the incremental, expanded, and you got the blur rate, etc. Everything is very similar. But then one thing we have to remember is that this blur radius, we have to test it out. We can't just put this as 0. Sometimes we want to put it as 1 or 0.2 or even 10, right? So it depends. But then, yeah, so like this one, we can, let's say, test it at 1. So the blur radius is about 1, which is, well, it's very normal for a mask blur. Then we're going to remap the mask range. So that's something that we can use for the mask. Like here, the mask inverter. Actually, this is like the invert mask itself. So it's the same concept as this one, the invert mask. But it just pretty much nicely compacts one node, one custom node that can pack up all these small nodes together. So if you want to use the mask inverter here, you can receive the background of the mask image. But this time we'll be using this one with the remap range. Make it like, 70s, something like that. Or in here, I like to set it like 30s to just kind of invert the mask a little bit. You can do that as well in here. But then actually we need one thing from here, which is that apply latent noise mask. That's by default in ControlNet UI. This one can be different from the other latent image custom nodes. So usually when we generate an AI image, we can use the empty latent image or the upscale latent like that. But then with this one, we're injecting the noise to the existing latent data, the latent image data. So in here, it's different, and we have the resize image. we have to put that in here as well. We can do this. First of all, we do a VAE encode and pass the original image latent and inject the latent mask that we've produced and inject it into the apply latent noise mask node here. So what it does is, it'll be the same concept as here. We input the image and then we cover it up with the mask and then we output something different like this one. So we need the VAE and that will be coming back to my old workflow. And yep, we have the VAE here. Let's put this into the loader group as well. For example, with the LCM models, we don't have a VAE, so we've got to use this one. Okay, so we have the VAE to get it in here. And lastly, we'll have the latent noise mask output in here. Let's check it out if there's anything we don't want. So in here, that would be the initial mask latent. I'll call this one in this way. So you can do that in here. And lastly, that will be the sampler. What I want to do in here, that'll be something easier to recognize, is that we pass this data. It's called the add model data. No, model AD data like that. And we'll pass this one out and also pass the mask latent out to the first sampling group. So we'll create one sampling group. So we'll call that the sampling one. So in here, we'll make another get node. Actually, two get nodes here. So first, we've got to get the model data. Second, we've got to get this initial mask latent. And the third one is resize image, if there's something we need. And of course, we need the conditions, positive and negative conditions. And mostly that's all we need. Then we pass to the K-sampler. Now the K-sampler, you can use the simple K-sampler or K-sampler advanced, but it's just up to you. Whatever you want to use here, you can convert the seed into input. So in here, like what I did previously, I have a global seed number and I put that into the loader group so I can copy this one. And this is the seed number. And I have the condition, negative and positive as well. And lastly, we have the mask latent image. Let it be running in here and let's try this one. Lastly is the VAE decode. And then for the VAE decode, we're going to use, of course, the VAE. Let's grab it from here. We don't have to type it again. And because we're using LCM, so we've got to choose LCM here. And you can choose the sRGB uniform or DDIM uniform. Whichever one you like is fine. Just test it with your image and stuff. For the LCM model, of course, we do load sampling steps, and let's go for CFG 1.5, just like what we usually do. And there we go. We have almost everything done. And lastly, we need the video combiner like this one. Let's bring this one. I don't want to type it again and again, so just copy and paste and do it in here. Yep. So we've got everything mostly completed, and we don't need the resize image. So let's try this time and see what we'll have in here. So our image is here, and we're going to do one more thing, which is restyling our characters. That means we need the IP adapter as well. So for the IP adapter, let's just copy my existing one. I don't need to redo that again. IPA for character only. Okay, so this is the group for the IP adapter, and we have the model base. So in this workflow, the names are a little different. We use model base, like what I used to do, and make it a little bit better. There we go. We have a beautiful one. Then I right now use the image background remover to, if any image, I want to remove the backgrounds and only keep the characters for the IP adapter, and I'm doing that as well. So that's one of the beauties of using the IP adapter and the image backgrounds remover. So here's the models of the IP adapter only. So we're going to get this one passed to our K-sampler. Actually, no, we should pass that to our animated diff connection. So let's get the animated models, and we get the models, the IP adapter character only models, and pass it to here. And before that, we have to get the base model data packet, pass it to our IP adapter, and then we have our output of model data that contains our IP adapter data in the model pipeline. So there we have almost everything complete, and let's try to run it one time and see. So right here, I'll be using this one just temporarily, bypassing everything, but then this is quite difficult using it like that. Let's separate another mask for the Coco segmenter. That'll be only for Coco segmentation masks. Then this one is for another method. So I'm going to click this one as disabled and use this to go and see what we'll have on the first run. Okay, so after I try that and implement everything, I'll check one more time. Remember, you have to select this mask for your IP adapter. So in this case, I've defined maskbots as person.gen that is related to this group. I'm using this person mask generator using this one. And if you use the Coco segmenter, let's say I have enabled this one, then you have to change the mask character with this label. So I'll temporarily disable this one and just focus on using this one this time, and we'll try it with masking our character, the dancer, and the dress is going to be in purple. So just very simple. See if the outfit of that will be changed to the IP adapter image. So let's click Generate, and we have the result here. So what I did was have this video as a source video run in 50 frames, then pass the IP adapter, the purple dress. Hopefully, we can do some color using these styles and influence the purely white tank top and the pants because it won't be fully changing the outfit of this character. It'll change the dress to this style of a long dress because we're using these very heavily influenced by the open pose, soft edge, and depth anything. You can always change the settings in here to play around with it. Sometimes you want to, do it lower. If you can do it like 0.3, that'll be less influence on the overall character's soft edge, but I like to go in the middle of things to just test it on the first try, and then we use the depth anything here. I don't put it fully to 1.0 on the strength here, so we pass the conditions to our Elementive. Next one is getting the mask. From here, we do the growth mask and blur mask, and then remap those ranges. Set it in the apply latent noise mask. And again, you can always test these numbers around. Like I don't prefer you go to like 1.0 or something. Just start testing with EO.7. If you're thinking that's too much for your video, then you can turn it down to like 0.5 or 0.6 like that in here. And then we're going to the model data using the IP adapter output data passed to the models. And we're getting the settings in the animated version 3 motion model to do our animations. Then obviously we use the free U version 2 and the differential diffusion that we talked about earlier in this video. Then we pass this data out to our first sampling step. So in here, we've got our model data and we got the latent mask, the initial mask latent data passed to the K-sampler and it runs. And I like to pass this data out for a second sampling, and this is the first sampling result. Although it's not really completed, the resolution is kind of low in the first sampling, as always, so I like to do the second sampling, which is passing the latent sampling image data, do a 1.5 upscale in here, and do another second sampling. Set the denoise to 0.3. Sometimes you want to do a little bit more. It's up to you. Like maximum, I would go 0.4 on the second sampling. If you do it too much, then the video will look totally unexpected. So this is the second sampling. It looks more clear. The outfit of the character changed, the face and the hairstyle changed, but we got the remnant of the background. That's basically because we just masked the person in here without doing the background influence. So yeah, that's it for this workflow, how it goes. If you want to change the backgrounds or something, of course you can do it in here. You can do like an invert mask in here, or you can just use the control net part in here, do an invert mask to, do a background mask for your IP adapter. Just like previously what we did in the old workflow, we do the mask data passed to IP adapter for influencing our backgrounds. But then there's always inconsistency in the backgrounds if we use that way or we use the control net input in here. It's up to you. So yeah, try it with different control nets in here. I would say that would be helpful. And also you can test other things like, for example, test the sampling steps as well. If you want to go like sampling at 8, then 8 to 6 on the first sampling is good enough. Don't go too high for LCM. If you're not using LCM, of course you've got to set it high. But normally we use LCM, then just 8 to 6 sampling steps is good enough here. So that's it for this result. We got, and other styles of characters with black hair, another face, and another color of clothing. And yeah, I've done other videos using this as testing before I did this workflow demo. That's this one. So this one is going to use Wonder Woman as the character. And then we change the hair, we change the outfit like that. And also the previous dance video, I'm using another outfit dress. But then that's only able to influence the top outfit because the IP adapter reference image is very strong on this example for the top outfit. So it's only able to influence that in here. Let me see if there's an example of this one. So like this one, the original outfit, and then this is the IP adapter image. Then that's how I got this result like this. And also the hair and the face is influenced by the IP adapter as you can see in here. Yeah. So you can play around with the settings always. It's not only one fixed way when I create a workflow and you're just going one direction using my settings. So that's it for these videos and hope you guys get some inspirations on how to create that. If you don't want to join Patreon to get this workflow, that's okay. You can just follow along with the videos and create this workflow by yourself. So don't blame me. Why am I not sharing this workflow to the public again? Cause I've explained that before in the previous videos, why I don't do that again. That is what it is. It sucks sometimes. If you don't like that, then please hunt for those guys who try to ruin the community. And I hope you guys enjoyed it, got some inspiration, and will play around with Comfy UI. Alright, see you later in the next video. Bye!